Okay, and there are some objects here placed here. So we have just studied the gravitational force now. So there I told you that if uh, there are two bodies of, if there are two masses, for example, there are two pens here. So in between these two pens, there is a force of attraction. That force of attraction is due to the masses of these objects, and that force of attraction is known as the gravitational force. Gravitational force. And there is one more term we have discussed, gravity. So today we will discuss the motion under gravity. So earlier we have seen that on different and on Earth there is a gravity of 9.8 meter per second square or kg per meter, and on Mars the gravity is little bit less. Okay, so today we will discuss the motion under gravity. Motion under gravity means uh, suppose this is a pen, and I am throwing this pen like this. I am dropping this pen like this. Okay, dropping this pen like this, this like this. So the motion of this pen when I am dropping this pen is the motion under the gravity. If there is no force, means there is a gravitational force. Okay. So motion under gravity. Earlier also we have discussed, but again I am discussing it. So motion under gravity we will discuss. Motion under gravity. Uh, so motion under, for the motion under gravity we can write the only force that is acting on the body is the gravitational force, and the body is performing the motion. Body performing motion when only force on body is gravitational. You can see if this body is moving from here to here like this, like this. So there is only one force, that is only the gravitational force is there. Okay, there is no other force. If this is the condition, then you can say the body is performing the motion under gravity. Motion under gravity. So if the body is going in upward direction like this is also the motion under gravity. And if body is coming downward like this is also the motion under gravity. So in motion under gravity, either the body will move up or either the body will move down. Okay. So suppose this is any mass, and this mass is moving in downward direction. Okay. So this is the downward motion. This is the downward motion. And this mass, suppose there is another mass, and this mass is moving in the upward direction.
Yeah.
Okay. So this is the downward direction. Downward motion, and this is the upward motion. Remember one thing, when the body is performing the motion under gravity, means I am dropping this pen. Always the acceleration of the body will be the acceleration due to gravity. Okay. The acceleration suppose you have thrown one ball like this in upward direction. When the ball is going up, what will be the acceleration of the ball? The acceleration of the ball will be g. That G means small g. And when
Yeah.
the ball is coming downward, then also the acceleration on the ball will be g. The acceleration uh, of body will be g is equal to 9.8 meter per second square, and this g is known as the acceleration due to gravity. Acceleration due to gravity. And this acceleration due to gravity is not depending upon the size of the body, not depending upon the shape of the body. No matter you are throwing this mobile phone, no matter you are throwing this laptop in the air, no matter you are throwing this bottle in the air, acceleration of this bottle, acceleration of this mobile phone, acceleration of laptop will be g. Okay, so you can write one more point about this g. This g is independent of shape, size, and mass of body, and mass of body. Okay, so one question I am asking. For example, there is one mobile phone, there is this object, and there is one pen. Both I am throwing like this. Suppose there is air friction is negligible. We are not assuming air around. Okay, we are assuming only the gravitational force. These bodies are performing the motion under the action of the gravitational force. Okay, these both bodies are performing motion under gravity. If I am throwing both the bodies, this have the more mass as compared to this. So can you tell me what will be the acceleration of both the bodies? Means which body will have the more acceleration?
The pen.
Why?
Because it's lighter and it has less surface area.
No. You are right. That in that extent you can be right. But I have just given one condition to you. The condition is that there is no air around.
Oh.
We are not assuming the air. Then I am asking the mass of this is more, as mass of this is less, and shape and size you can see, and shape and size you can see. So both are going in downward direction. So now tell me which one have the more acceleration, or
The phone.
can
The phone.
no, both will have the same acceleration. That is 9.8 meter per second square. I have told you now, this acceleration, when the body is performing the motion under gravity, when there is a motion of the body under the gravity only, when the motion of the body will be under the gravity only, okay, then the acceleration of any body will be 9.8 meter per second square on earth.
Okay.
So note down this point, otherwise you will forget. If anybody is moving under gravity, then the acceleration will be g is equal to 9.8 meter per second square, and this g is known as the acceleration due to gravity. Simply remember, if there is a motion under the gravity, then there will be the acceleration due to gravity.
Yeah.
This g is the acceleration due to gravity. Okay. And see, this 9.8 is a constant value or variable value?
Constant. No,
Huh.
variable.
This 9.8 here I am saying is a
Yeah,
constant,
here.
na?
Yeah, constant.
Here is constant. G is equal to 9.8. Meter per second square is constant. So what is G?
X.
Acceleration, na?
Yeah.
G is the acceleration.
Yeah.
So means the acceleration is constant.
Yeah.
Okay, very good. And what is the motion in which the acceleration is constant? What is the name of the motion in which the acceleration is constant?
Downward.
Uniform accelerated motion.
Okay.
You can see here. Please show some interest. Uniformly accelerated motion. Uniformly accelerated motion. Acceleration is constant.
Okay.
And if the acceleration of any motion is constant, the equation of motions are valid. These three equations of motion are valid for that. Last class also I told you acceleration is constant, then you can say that the motion under gravity, the motion under gravity is the example of uniformly accelerated motion. Uniformly accelerated motion. Step by step, I am telling step by step. So that there should be no confusion. Now, please write down this on your copy in a proper manner. Okay. It will help you in your exam. Write down properly. Done?
Yes, I wrote it down.
Okay. Scroll down. Look.
Yeah. Okay, sir, I wrote it down.
Okay. So now, means the gravitation, means the motion under gravity is the example of uniformly accelerated motion. Uniformly accelerated motion. So if this is an example of uniformly accelerated motion, then equations of motions are valid.
Hmm.
Equations of motion are valid. Are valid in motion under gravity. So first equation of motion, what is first equation of motion? V is equal to U plus AT, U plus A into T. Second equation of motion, S is equal to UT plus half A T square. Third equation of motion is equal to V square is equal to U square plus 2 into A into S. What
Hmm.
is V? V is the final velocity.
Yeah.
V is the final velocity. Small u is the initial velocity. Is the initial velocity. Again and again I am telling. And A is the acceleration. A is the acceleration.
Hmm.
And this acceleration is constant. Constant means not changing with time or distance. Constant means not changing.
Hmm.
Okay. After this, that S is the displacement. Okay. And T is the time. T is the time. T is the time. Now we can apply the equations of motion when the body is performing the motion under gravity. So now we will use these equation of motion to solve some of the problems. Some of the problems. For example, uh, For example, now see here. Suppose this is the ground.
Yeah.
This is a ground. Before that, I want to tell you one more thing. When we are using the equations of motion, na, so there should be one sign convention is there. Sign convention.
Mm.
Sign convention means upward direction you will take positive.
Mm.
Upward direction. Upward direction. You will take positive direction. And downward direction, you will take negative.
Mm.
You will take negative. Upward direction, you will take positive. See here, if the velocity is in upward direction, then that velocity you will take positive.
Mm.
If the velocity is in negative downward direction, then that velocity will be negative. If the
Yeah.
displacement is in downward direction, that will be negative. Okay, and one more point. Remember one more point. Acceleration due to gravity will always be in downward direction. G will always be in downward direction. What is the reason behind it? The reason behind it is this is a pen, and this pen is dropping like this. Always it will go in downward direction. Always it will go in downward direction. Why it is going in downward direction? Because this earth surface or the center of the earth is applying an attracting force on this pen, so that this pen is going in the downward direction. So acceleration of this pen will always remain in downward direction during motion under gravity. So G will always be in the downward direction. So G you will always take negative.
Okay.
Now we will discuss this example. Suppose there is a ball here. This is a ball.
Yeah.
Okay, this is a ball. And this ball is dropped from the, this ball is dropped from height h.
Mm.
This height is h. This ball, suppose this pen is a ball, for example, and this is dropped. This is
Yeah.
dropped like this from some height from the ground. Height from the ground. If someone is asking, find the time taken, uh, find the time taken by a ball to reach the ground.
Yeah.
Now this is very beautiful question. Ball is here, you are dropping this ball, and this ball is under gravity. This ball is performing the gravitational, means performing the motion under only the gravitational force. And you have to find at what time, means how much time it will take to reach the ground. So how can we solve this question? We will use the equation of motions. We will use equations of motion. So now you can see the motion of the ball from here to here. Just observe the motion of the ball when the ball is just dropped and when the ball is just reached the ground. So you can take the initial velocity. What will be the initial velocity? Initial velocity of the ball is equal to 0. Okay. Initial velocity of the ball is 0. And displacement of the ball is in the downward direction.
Yeah.
Okay, because the ball is going in the downward direction like this.
Yeah.
Displacement is in the downward direction. Displacement of the ball is in the downward direction. So displacement is in the downward direction, and we will take displacement negative minus h, because this displacement is in the downward direction. And what is the acceleration of the ball? Acceleration of the ball is the acceleration due to gravity, that is g, and g is always in the downward direction.
Yeah.
So that is why you will take g also as a negative. Now apply this equation of motion. S is equal to ut plus half a into t square. You want to find the time taken to reach the ground. Time taken by the ball to reach the ground. Okay. Acceleration in this case is minus g, and time you have to find to reach the ground. So now put the value. What is the displacement? Displacement as you will put minus h. Initial velocity is 0. Okay, this u is 0. You can see here. Plus half. Acceleration you will take minus g. And time you have to find. Okay. So here this is minus h. This term will become 0 into t is 0.
Yeah.
And here you will have minus half gt square. Minus half gt square. Okay. So you will have basically minus h is equal to minus half gt square. Now this minus and minus will be cancelled out. So from here you can find the value of t. So that value of t will, you will multiply this with this h. So it will become 2h divided by g, and this is equal to t square. When you will find that time t, that will be under root of 2h by g. Now you can see here, this time is not depending upon the mass of the ball. Not depending upon the mass of the ball. Okay. So you can say independent of mass of the ball. Note down. Note down these equations of motion again. And please remember these equations of motion. Then when will your exam will be conducted? When your exam will be conducted?
We don't know yet because it's holidays right now. So they didn't tell us.
Okay.
Sir, can you scroll down?
Rayyan, do you have the PDF of your science or physics book?
No, it didn't give me a PDF.
Okay.
I only have the hard copy.
What is the name of your book?
Uh,
I think you already told me,
yeah, it was
but I
M5.
okay, no problem. No, write down, then we will discuss that.
Sir, can you scroll down?
Yeah. Done?
Yeah.
So have you understood now how you will calculate the time taken by this ball to reach the ground?
Yeah.
You will apply the equation of motion.
Yeah.
Then you will find the time taken by the ball to reach the ground.
Mm.
Okay. After that, if they are saying same condition given to you, this is the ground and uh, the ball is dropped from a height. For example, this pen is dropped from a height, or this pen is dropped from a height. So this pen is performing the motion under the gravitational force, the motion under the gravitational force, or here the ball is performing the motion under the gravitational force, and this ball is going in the downward direction. We know already. Okay. And acceleration of this ball will be minus g.
Yeah.
Why we have taken here minus sign? Because g will be in the downward direction.
Yeah.
Very good. And this ball is dropped from a height h. Okay, no problem. Suppose if they are asking velocity with which the ball will strike this ground. What? Velocity of striking. Velocity of striking of ball with ground. Can you try this to find out the velocity of striking of ball with ground?
Yeah.
Okay, okay. One more thing. You have to apply the equations of motion. Okay. So equations of motion. These are the equations of motion. Okay. So you can check your notes. Okay. Now you have notes. That is why I am saying again and again, make your own notes. Make your own notes. Okay. So just try. What will be the velocity at this point when the ball will strike? Try to think by yourself. Try to apply the equations of motion. Ryan, is my video breaking or
Yeah.
it's fine? Hmm?
It's breaking a little.
Actually, Ryan, I think your internet connection is not okay. Your video is also breaking.
I don't know.
Have to check. Completed? Okay, just try to solve it. Okay, I am joining meeting again. Okay.
Okay.
Hello, Rayyan.
Yeah, sir.
Have you completed that?
I think so.
Okay, just wait.
Yeah.
Okay, now it's okay. Huh. See, just check your answer if you have
Yeah.
completed. Very easy. This was very easy question. Means you have to find the. Just open your video, please.
Yeah.
Focus mode is on. Problem. We have to find the velocity when the body will be here. Means final velocity we want to find. So we can apply this equation of motion v is equal to. Before that, first we will check what is given. So first of all, displacement of the body is minus h, because displacement of the body is in the downward direction,
Yeah.
and acceleration of the body is minus g.
Yeah.
Okay. One more thing is given, that is time. Time is given as 2h/g, just calculated above. This is the concept that you have to apply. Time taken for this ball to reach from here to here is root 2h/g.
Yeah.
Now you can apply v is equal to u plus at, and what is the initial velocity? 0, because you are dropping the ball. Dropping the ball means the initial velocity is 0. Now you can find the velocity. V is equal to final velocity is equal to initial velocity 0. Acceleration is minus g, and time you have 2h by g. Time you have 2h by g. Now the final velocity will be minus of g under root of 2h by g. Now this negative sign is here now.
Yeah.
This is the negative sign. So this negative sign is showing that the velocity is in the downward direction. Obviously, the velocity will be in the downward direction. If you will check here, the body will going in the downward direction. So at the point of striking, the velocity will also be in the downward direction. Now my video is okay.
Yeah.
So see, in this way you have to calculate. This is the negative sign, and this negative sign is showing that the velocity is in the downward direction.
Yeah.
Okay, so what you should do? This figure you have now already. You have drawn this figure now.
Yeah.
So what you have to do? Just write the velocity of the ball striking off the ground and write down only this part.
So I got to correct to the second last step. I just didn't do the last one.
Oh, you have done this till here.
Yeah, I did. Yeah, I did it till here. I didn't do the last one.
Very good, very good. Means you are understanding now things. You're getting the things. So Rayyan, what happens when we take interest in something? Okay, then we are able to understand. If you will not take the interest, then for me also it is very difficult to understand to explain anything. If you will take the interest, if you will make the notes properly, then there will be no problem. Each and every question you can solve, and in exam also you will perform better.
Yeah.
Your video is breaking. I don't know why.
And my Wi-Fi, I don't know. I think there's something wrong with it. I'll check it.
Okay, no problem. Fine. I think my Wi-Fi is fine.
Yeah, I think it's mine.
Yeah.
Okay, so I wrote.
Done now?
Yeah, I know.
So okay, so do one thing. Uh, uh, After the class, do you have my number now?
Yeah, I have.
Phone number?
Yeah.
You have now? So
Yeah.
just send me the front page of your book. Okay?
Okay.
Okay, send me the front page of your book. Okay?
Okay. Yeah. Okay.
After the class of the physics book, science book. Okay? Okay, so now we will meet in the next class. Okay?
Okay.
Okay, fine.
Goodbye.